Welcome to my channel. Today we are going to discuss about one important theorem in circuit analysis. It is called as a superposition theorem. Okay, so already you know the use of this theorem, Thevenin's, Norton's, superposition and source transformation. This thing is that in order to solve the circuit in an easy way, we are using this different theorems. Okay, so what is the use of this superposition theorem means? Using this theorem, we can find current through any branch or the voltage across any element we can calculate in a linear circuit. Okay, it is important. The superposition theorem is applied only for linear circuit. Okay, for non-linear circuit, this superposition theorem will not valid. Okay, and the superposition theorem, it is valid for the circuit consisting of two or more sources. Okay, in a given circuit, that circuit must have at least the two source. Okay, two or three more sources. For that circuit only, we can apply the superposition theorem. If the circuit consisting of only one source means the superposition theorem will not apply. Okay, so the three things you just remember. In order to find the current flowing through the particular branch or voltage across any given element is calculated using the superposition theorem, and the superposition theorem is applied only for linear circuit. Okay, and that linear circuit must consist of two or more sources. Okay, it is important. And according to this superposition theorem, so what is the statement for this superposition theorem means? So first you see, in order to read the statement, so first you just see the circuit. So this is example. For example, in order to explain the superposition principle, I am taking one circuit. So in this, there are two sources is there. One is this voltage source of value 20 volt, and another one is a current source of 4 amps. Okay, so here the question is that can find the current flowing through this 10 ohm resistor. Okay, so that is our question means, according to this 20 volt also, there is some current flowing through this 10 ohm resistor, and depending upon this 4 amps current source also, the current is flowing through the particular resistor. Okay, so if you want to find the total current flowing through this 10 ohm resistor, and in order to prove the superposition principle, so first we have to activate one source. Okay, so this first time, okay, in case one, step number one, you just activate this first source. 20 volt battery is inactive, and you just deactivate this 4 amps current source. Okay, so due to this 20 volt current source, what is the actual current flowing through this 10 ohm resistor? You just find, you take it as a I dash. Okay, I dash or I1 you take. Then in next time, in second time, you just deactivate this voltage source, and you just activate this current source, and because of this current source, what is the current flowing through this 10 ohm resistor? You just find out, it is said to be I double dash. Okay, then what is the actual total current flowing through this 10 ohm resistor? Due to this 20 volt and this 4 amps current source is that the addition of this I dash and I double dash. Okay, so this is nothing but a superposition theorem. Okay, so you see the statement, in a linear circuit containing more than one source, the current that flows at any point, or using this superposition theorem, we may calculate voltage also. Okay, instead of current flowing through this 10 ohm resistor, the question, there may be find voltage across this 10 ohm resistor. Okay, so the voltage that exists between any 2 point is the algebraic sum of currents or voltages that would have been produced by each source taken separately with all other sources removed. Okay, so in order to calculate this total current I flowing through this 10 ohm resistor, so in superposition theorem, first you have to activate only one source. Okay, first time this source you activate, you deactivate this source. In second time you activate this source and you you activate this source and you deactivate this source. So you find the current separately. Then the addition of the algebraic sum of these two current is the actual total current flowing through this 10 ohm resistor. So this principle, this is said to be the superposition theorem. Okay, and so in order to solve the superposition theorem, so you just note down this important points. That is, when we are solving the superposition theorem problem, so first we have to consider only, that is, we have to activate only one source at a time. Okay, so for example, if we are activating this voltage source and we are deactivating this current source means, okay, that is deactivate means we have to remove this branch. Okay, so we have to remove this entire branch. So at the time, this ideal current source is replaced by open circuit. Okay, that is the thing. Then if you are deactivating this voltage source means at the time we have to make short circuit. In the place of 20-volt battery, there is a short circuit is there. You just consider. Okay, so these are all the points you just remember. So you see the removal of ideal voltage source. Okay, so if you are removing one voltage source means that place is replaced with short circuit. Okay, while deactivating the voltage source, that voltage source place you just remove, and we have to place one short circuit. And the removal of ideal current source means replacing it with open circuit. Okay, if you are removing this current source means you just open circuit this branch. Okay, so here entirely discarded. And if you are removing practical voltage source or current source means, okay, this is the ideal voltage source and current sources. That is ideal voltage source and current source means the internal resistance of that voltage source current source is 0. Okay, but practical voltage source current source means it is internally having some resistance. Okay, when we are removing that particular voltage source, practical voltage source and current source, we have to replace it with some internal resistance given in the question. Okay, so these are all the points you just remember. And using this superposition theorem, so it can be applied to calculate current through any branch or voltage across any particular element, already you know. And it can be applied for linear circuit. And in order to solve this problem, the circuit must consist of more than two sources. Two sources or more than two sources. Okay, and it cannot be used for the calculation of power. Okay, so this superposition theorem is it can be used only to calculate current and voltage. Okay, current flowing through any element or voltage across any element. But the superposition theorem is not used to calculate power. Okay, since power is a non-linear value. Okay, so the power calculation we can't done using the superposition principle. Okay, so this is the superposition principle, and using this superposition theorem, we are going to solve one problem in this video. Okay, so you see this is the May 2018 question. Okay, so here this question we are going to solve using superposition theorem. Okay, so you see the question, calculate the current in 4 ohm resistor. So where is the 4 ohm? This is the 4 ohm resistor. We have to find current flowing through this 4 ohm resistor using superposition theorem. Okay, this is the question. And you see this circuit first. So in the circuit, superposition theorem is valid for if the circuit consisting of multiple sources. So here you see the two sources are available. One is this 10 volt voltage source and another one is a 1 amps current source. Okay, so because of this voltage source and current source, what is the actual current flowing through the 4 ohm resistor? We have to solve using superposition principle. If it is a superposition principle is not mentioned means, so using mesh analysis, we can calculate the current flowing through 4 ohm resistor because of both this voltage and current source at a time. Okay, but here we have to use the principle superposition principle. Okay, so what is the first step in that superposition principle? In a two sources are available means at a time we have to activate only one source. Okay, so in the given circuit there are two sources, 10 volt voltage and 1 amps current source. So the step number 1 is by activating the 10 volt voltage source and deactivating the 1 amps current source. Okay, so you activate this, only this source you make active, and this 1 amps current source you just deactivate. Okay, so already you know, if you are deactivating the current source means that the current source is replaced by open circuit. Okay, so you just remove this current source. So in the place of that current source, there is a open circuit. So now the diagram Okay, our given diagram is converted to like this. Okay, so since here the current branch, the current source branch is just open circuited. So now we have to find current flowing through this 4 ohm resistor. It is our question. So in order to find current flowing through 4 ohm resistor, you may use any method, mesh analysis, nodal analysis, anything you can use. Okay, so our well-known method is a mesh analysis. So we are going to solve current flowing through 4 ohm resistor using mesh analysis. Okay, so you follow mesh analysis procedure. What is the mesh analysis procedure? You just find how many meshes are there. Only two mesh. This is the mesh 1, mesh 2. And let us consider current flowing in the first mesh is I1, current flowing in the second mesh is I2. Okay, then you just write KVL for first loop and KVL for second loop. Or otherwise, you may write, that is in inspection method, you may write directly the matrix. Okay, so the inspection method already you know. So here 2 loop means we can get 2 cross 2 matrix, the current I1, I2 equal to the constant voltage. Okay, so what is this? The first element. The first element is a R11. What is R11? Total resistance in first loop. So 3 plus 4, 7. Okay, then what is this? It is a R12. R12 means the common resistance between first loop and second loop. Which one? 4. In order to mention the common element, we have to put minus symbol. So minus 4. Similarly, this is R21. R21, R12, both are equal only. So the same 4 you just substitute. Then here it is R22. What is R22? Total resistance in second loop. So 2 plus 2 plus 4. So 8. Okay, 8. Then I1, I2 equal to voltage rise in first loop and second loop. So what is the voltage rise in first loop? So in first loop, there is a voltage source there. So you see in this direction, minus to plus, it is a voltage rise 10. In second loop, there is no voltage rise. So 10, 0. Okay. So directly using inspection method from the diagram, if you know the inspection method means directly you can write this matrix. Okay. Or otherwise, you write KVL equation for first loop separately, and you write KVL equation for second loop separately. So you see, we will get the equation 7I1 minus 4I2 equal to 10, minus 4I1 plus 8I2 equal to 0. Then if you are converting this two equation into matrix, we can get the same answer. Okay, so you can use direct inspection method, or you write KVL, then you convert into matrix. Okay, so now our aim is to solve I1 and I2. Okay, so if you want to find out the variable I1 and I2, so you just find del value first. So del value, the determinant of this 2 by 2 matrix, 7 into 8 minus of minus 4 into minus 4. So the answer is 40. Okay, then you find del I1. So you know del I1. In this 2 by 2 matrix, you replace this first column by this constant means it is a del I1. If you are replacing this second column by this constant means we can get del I2. Okay, so del I1 is 80, del I2 is 40. So after calculating del I1, del I2, you just find I1 and I2. So I1 is now 80 divided by 40, 2 amps. I2 is 1 amps. Okay, so I1 and I2 calculated. So what is our aim? Our aim is to find out current flowing through this 4 ohm resistor. Okay, so what is the current flowing through 4 ohm resistor? This current flowing through this 4 ohm resistor, it is nothing but this 4 ohm is common for loop 1 and loop 2. So I1 current is flowing in this direction. I2 current is flowing in this direction. So the current flowing through 4 ohm resistor is nothing but I1 minus I2. Okay, I1 minus I2. So therefore, the current flowing through 4 ohm resistor, you just consider as a I dash. Okay, current flowing through 4 ohm resistor due to 10 volt voltage source alone is I dash. It is I1 minus I2. So 2 minus 1, 1 amps. Okay, this is the first step. So in this first step, we are activating the first voltage source, we are deactivating the current source, and we are calculating the answer. Okay, similarly, in step number 2, okay, in step number 2, you just activate the current source and you deactivate the 10 volt voltage source. At the time, you just find the current flowing through this 4 ohm resistor. Okay, so in our given diagram, okay, so you take the first diagram. So in our given circuit, In second step, you just activate this 1 amps current source and you have to deactivate this 10 volt battery. Okay. So while deactivating this 10 volt voltage source, so what about this 10 volt voltage source? It becomes short circuit. Okay, already you know the concept. If current sources are zero means in the place of current source, you just open circuit it. Okay. In place of voltage source, we have to short circuit it. So that's why this diagram is converted into, so you see the diagram. Now we can get 1 amps current source, 2 ohm resistor, 2 ohm, 4 ohm and 3 ohm. Now our aim is to find out current flowing through this 4 ohm resistor. Okay, so we can use any method you can use in order to find out the current. Okay, so here there is a 3 loop circuit is there. So now we are going to see that is we how to apply source transformation technique, since you see this 1 amps and 2 ohm resistor connect in parallel. Okay, so the 1 amps connect in parallel with the 2 ohm resistor, you may convert into voltage source in series with resistance using source transformation technique. Okay, so that's why. So what is the value of this voltage source? 1 into 2, 2 volt in series with the resistance. Okay, so you just replace this 2 branch by 2 volt in series with resistance, and the remaining resistance you just as it is you connect. Okay, now you see 2 loop circuit. Okay, this 3 loop circuit is converted into 2 loop circuit. Now you can use mesh analysis in order to solve the current flowing through 4 ohm resistor. Okay, so here how many meshes? Same, 2 meshes. So let us consider current flowing in the first mesh is I1, current flowing in the second mesh I2, but here the I2 direction is anti-clockwise. Since here the battery plus is here. Okay, always current emerging from positive terminal of the battery. So that's why here the current direction is anti-clockwise, here clockwise. Okay, now so for the circuit we can't apply inspection method directly, since in order to apply inspection method both mesh currents are in clockwise direction, but in this case one current is clockwise, another one current is anti-clockwise. Okay, so you just write KVL, then you convert into matrix. That is the correct thing. Okay, so you just apply KVL to this first loop, 3I1 plus 4 into I1 plus I2. Since two currents are same direction, 4 into I1 plus I2 equal to 0. So we can get one more equation, 7I1 plus 4I2 equal to 0. Okay, this is, you take equation number 3. Similarly, you write KVL for this loop. So 2 equal to 2 into I2 plus 2 into I2 plus 4 into I2 plus I1. Okay, so from that you got another one equation, 2 equal to 4I1 plus 8I2. Okay, so by solving these two equation, you see, you convert into matrix, then you find del value, del I1, del I2. Okay, after that you just find I1 and I2. So I1 is minus 0.2 amps, I2 is 0.35 amps. Okay, so what is our question? After calculating this mesh current, our question is to find out the current flowing through this 4 ohm resistor. Okay, so what is the current flowing through this 4 ohm resistor in this diagram? It is the addition of I1 and I2. Okay, since both currents are flowing in same direction. Okay, so that's why current flowing through 4 ohm resistor due to the 1 amps current source is I2 plus I1. Okay, so you just consider that current as a I double dash. Okay, so the I double dash answer is 0.15 amps. Okay, so in in first step, okay, in superposition theorem, in first step, we are activating this voltage source. Because of this voltage source, what is the current we calculated? It is a I dash. Okay, in second step, because of this 1 amps current source, the current flowing is calculated, it is a I double dash. Okay, so both, due to both the source, what is the total current flowing through this 4 ohm resistance means it is the addition of I dash and I double dash. Okay, so that is the step number 3. So you see, step number 3 is therefore total current flowing through 4 ohm resistor is the sum of current due to 10 volt voltage source and due to 1 amps current source. Okay, so the total current I equal to I dash plus I double dash. So 1 plus 0.5, so 1.15 is the answer. Okay, this is the actual current flowing through the 4 ohm resistor. Okay, so this is said to be the superposition theorem. If the superposition theorem is not mentioned, means in a using mesh analysis or nodal analysis, we can solve the problem directly. But that is, we are verifying the superposition theorem here. So if the superposition theorem is verified, means the given circuit is a linear circuit. Okay, that is a meaning. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. If you want to learn that is the problems related to this circuit analysis. Okay, so already I posted many university problems related to KVL, KCL, mesh analysis, nodal analysis. Okay, for DC circuit as well as the AC circuit. Then current division theorem, voltage division theorem. Okay, source transformation technique, star to delta conversion. Okay, so I posted several videos for the circuit analysis. So all videos are available in the name of circuit analysis playlist. One that is lecture videos are available. Then in the name of circuit analysis MCQ, the 2-mark problems. Okay, 2-mark problem in topic wise I solved. In that circuit analysis MCQ video, only 2 marks available. The big questions, okay, 5 mark, 6 mark, 8 mark, and 13 mark question is available in the circuit analysis playlist. Okay, so please watch that one, or I will give link for that playlist in the description box. You can refer it. Okay, so thank you. We will meet in the next video with one more problem.